that is started now.
Okay. There are several variabilities like standard deviation, average deviation, range, like that. Variance is also important indicator for the variability within the groups and between the groups. Now, when we are applying the analysis of variance, then we are assuming that there are more than two groups, and we have to find out mean differences among the different groups. When we have two groups, usually we use the t-test. We can use the ANOVA also, but usually we favor t-test, students t-test. But when there will be more than two groups, then we can use the analysis of variance. So in analysis of variance, our assumption will be that dependent variable will be only one. And the variable, that is the independent variable, it should have two levels. For example, gender is the variable, and there are two levels. One is the male, another one is the female. So when nowadays we can think about the transgender. So suppose I collected data from the three groups, male, female, and transgender. Then I can use ANOVA, and this ANOVA will be one-way ANOVA. In one-way ANOVA, there will be one variable, but two levels. Sorry, more than two levels. Okay, for example, gender is the variable, and three levels are there, male, female, and transgender. Suppose you want to examine effect of education on emotional intelligence. Then your emotional intelligence will be metric data. It will be your dependent variable, and education will be the categorical variable with three levels. So this level and variable, this is clear to all of you? Okay.
Yes, sir.
So in SPSS, we have to define the dependent variable as well as the variable that is the categorical variable. We should indicate. Okay. Now I am sharing the screen. Is it visible to all of you?
Yes.
Okay. Now here you can find out the gender. And this is the educational level. Okay. So initially you have to find out how many data you have. That is your frequency distribution. This is vital. I click frequency, then I click gender. Now I click OK. So now I find that is the male 24, female 6, and transgender will be the 10. Okay, so I have to modify because it indicates 3. I should modify.
Sir, output screen is not visible, sir.
Okay, one sec. Okay. Okay, now this is clear, na? Is it visible?
Yes, sir.
Okay. So first I have to click the analyze. Then descriptive statistics. Then frequencies. I can select sex and education. This is visible. This frequency is visible. Window. Okay, not visible. Then I am sharing again. Now it is visible. Okay. So I click OK. Now I find sex wise. So sex is the variable. And there are 3 levels. Male 24, female 6, and transgender 10. Okay. So initially,
I can't see the screen.
screen is not visible.
The sixth one.
Okay. Now it is visible.
Yes, sir.
Okay. So total data is 40. And this 40 so sex is the variable. And I find the 3 levels. One is the male, second female, third is the transgender. Okay. That means 3 groups I get. Now I am going to the another one. That is the educational data. 9 is graduation, post-graduation 21, and diploma holder is 10. This is clear? So when you want to do the one-way ANOVA, first you have to check whether your frequencies are for each group more than 30 or not. Here sample size is very small because it is a training data. My suggestion, you always keep in mind that these 3 levels, the data should be more than 30. Here I am presenting the data, which is training data. For your analysis, you can get it. But please, you do not use ANOVA if it is not more than 30. So this is the vital point. Okay, now I am going to check whether there is a mean difference or not. Therefore, first I click the graphs. Now again, I am changing. So I have to, please you tell me whether it is visible or not. First, I have to click graphs. Then legacy dialog. Then I will click the box plot. There is one summaries of separate variables. Then I have to click the simple. Then define. So I am taking this data, total essay in the boxes represent. Then OK. Now I get the box plot. This box plot is visible to all of you?
Yes, sir.
Okay, in the box Whisker plot, it is called the box Whisker plot. There are 6 hinges. 1, 2, 3, 4, 5. No, 5 hinges. First hinges, that is the maximum data. Second is the quartile 3. Third is the quartile 2. Fourth is the quartile 1. And this is the minimum. Or from here, if you think minimum is 1, quartile 1 is 2. This is the quartile 2. This is 3. And this is quartile 3. This is 4. And this is the maximum data. So it will be the 5. So 5 hinges are there. Okay. Now, this is the box. The box is very important. Now, the box from quartile 1 to quartile 3, this is called interquartile range. Okay, this is called interquartile range. So, if you think that is this is basically the median. This is the quartile 2, this line. This is the median. Okay. And if you find that is there is no line or no hinge upper the quartile 3. Okay. And quartile 2 lies here. So in quartile 3, quartile 2 is there. What does it mean? That means more number of people possess this value. Okay. Because this is the median. And if you find that this box is very small, that means less number of people possess the score. And if you find that there is no hinge above the quartile 3, but quartile below the quartile 1, there is hinge. That means less number of people possess that particular score. This is clear to all of you? Or if you have any question, you can ask me.
Sir, can you please explain interquartile range?
This is the from quartile 1 to quartile 3. This is called the interquartile range. Okay. Now, I am showing you the distribution of data. Again, now this is the graph. Legacy dialog. I am selecting box plot. class chart. Then define, then total essay will be here, and the shakes will be the category axis. Okay. What happened? I hit rows. No, it is not the labeling. Okay. I am taking these variables, self-awakening, not the class chart. I'm checking just. There is another variable, describe, legacy dialog, box plot, simple, then define, after that self, yeah. Suppose I have done this one. Now I get box plot. Now can we see that is the box size is very small for other data because I have used this particular variable. Here the score is high. So if I want to remove this one, then I may get better data. The scale value is high. Therefore, I am not getting good data. So again, I have to click the define variable, and this total essay that will be separated. Now I click it again. Okay. Now here you can find out the data's pattern. That is very nice. This is clear. So 5 variables are there. Okay. That is the 5 items are there. And this is the box whisker plot. First and second item, many people possess very lower score. Lower score means 1 also, but not in case of 3, 4. Okay. In case of 3, 1 is the outlier. This 18 number cases is the outlier. And again in 5, variable number 5 you will find that is 1, 2, 3, 4. So 4 cases are outlier. Therefore, you must be very clear about whether your data has any outlier or not. Okay. So if there is any outlier, first of all, you have to find out whether this outlier is justified or not. If the outlier is justified, then you can keep. If it is your printing mistake, typing mistake, then you have to remove this outlier. Okay. This is clear?
Yes, sir.
This outlier issue is clear? Okay, now here you can find out the median. Here you can find out that the middle, there is a median. But particular in the 5th number of item, you will find the median and first quartile is in the same position. Okay, and the box size is very small. That means this data may have some problem. This particular data, this particular item may have some problem. We do not know. So we have to check, that is whether why this data has such problem. Then we have to do because what is our assumption? Our assumption is that all the 5 items will be correlated with each other. So we have to check whether these 5 items are correlated with each other or not. If they are not correlated, then we cannot make any total score. Okay. So you must be very careful about it. Now I want to find out, is there any correlation among the 5 variables or not? So this is the correlation data. I find that is the SA1 and SA2 is significant. SA1 also significant with SA4, but not SA5. SA5 is not correlated with other variables or with other items except SA4. SA4 and SA5, the correlation is there, 0.47, and that is significant. But others are not correlated. Okay. For training purpose, I keep SA5, but for your doctoral work, you cannot use this SA5. For training purpose, I am using. So now I click Analyze. Then Compare means. Compare means, here you can find out one-way ANOVA. So one-way ANOVA, I can show one dependent variable will be there and one explanatory variable with more than 2 levels will be there. So this is your dependent variable. And this is your independent variable. Okay. Now I click because it has the 3 groups. Therefore, I can do the Tukey test. Tukey then I click continue. After that, okay. So here you can find out this is the ANOVA result. Now I am showing you ANOVA result. This is the ANOVA result. Okay, 3 groups are there. So that between group degrees of freedom is 2. And within group is 37. This is the sum of square and this is the mean square. So sum of square divided by the DF will be the mean square. And between group means, so this value divided by within group mean square, that is the F value. And the significance is 0.11. That means this is not at all significant. Since it is not significant, the multiple comparison is not very much justified. Okay, but for your understanding, if you find that this is significant, then you have to show that is between groups, whether it is significant or not. Since we find there is no significant difference, here we are also finding out there is no significant difference between the groups. For example, that is the male, female. This is the transgender. So male versus female, there is no significant difference. Even the male versus transgender, there is no significant difference. This is clear?
Sir,
Hello? Yes.
if we find that there are no significant difference between two variables, that means the data set is not good.
No, if my hypothesis is that there will be no significant difference because it is the universal value. So that possibility is there. So I cannot say it is not good. There is no question of good, bad. It is basically depending upon your hypothesis. So my hypothesis is that self-awakening is the universal values. So there will be no difference among the groups. That means this is theoretically correct. Okay.
Okay, sir. Okay, sir.
So it depends upon your hypothesis. Now, okay, since there is no significant difference, my hypothesis is there will be no significant mean differences among the groups. That is male, female, and transgender, though they have some level of difference with respect to their here you can find out, explore. Total essay, dependent, then sex is the factor. Now I put okay. This is visible to all of you? No. Before the ANOVA, you will do this analysis. Okay. This is the explore. So you can find out the statistics by groups. Here it is written plots also. You can click the histogram. That is better. After that, you click continue. Then click OK. So now you can find out the total essay mean is the 19.70. "24 people are there, male 19.70, female is 19.17, and transgender is 17.30. So by the mean, we can find out that the transgender's mean is lower in comparison with the male and female, but ANOVA shows there is no significant difference. And we have to follow the significant difference. Next, I click the histogram. This is for the male. This is for the female. This is for transgender. This is Template plot for male, female, and this is the transgender. Now this is the box whisker plot. Okay, so this is the box whisker plot. Box whisker plot visible to all of you?
Yes.
So this is the box whisker plot. So here you can find out that is the transgender's mean or median that is lower than the other two groups. But you cannot make any generalization because there is no significant differences among the three groups. This is clear?
Yes, sir.
So when you show the ANOVA, then it is better to indicate the box whisker plot if you find that is the mean differences among the groups are significant. Okay. Now I am requesting Ankit to share the screen. Ankit, are you here? Hello, Ankit. Ankit, are you here? Hey, Farah, where is Ankit?
Sir, am I audible now?
Yeah, you are audible. So please share the screen, your PPT.
PPT. I have to join from other device. Sir, wait for 1 minute. Give me one moment.
Okay. Okay, students, do you have any question? Okay, now I am asking you some question. Please you tell me. That is before analysis of ANOVA, what are the things we have to test? What are the things we have to test? First one is the sample size. That is the frequency distribution. Of the different groups. Therefore, first we have to click descriptive statistics and then explore. If you click explore, then you can get it. Before Ankit coming, I can show you another thing. That is the one-way ANOVA. Instead of checks, I can show you the differences across the educational level. Okay.
So is my slide visible now?
Okay, now please share.
So I've shared my screen.
Okay, you are visible, huh? Please read it. Achha, first you have to cancel. There is one window caption language. Hello, Ankit.
Yes, sir.
You click the save.
Click the.
There is one window. Set the caption language for this meeting. Save and cancel.
Can't find anything.
What is this? I do not know.
It's not visible from my end.
Oh, what I see. Students, have you seen it? Save and cancel.
No, sir. There are the scheme where is written what is ANOVA and definition of ANOVA.
But I am watching save and cancel. Okay. Okay, now you present. Now Ankit tell.
Okay. My screen is.
Share the screen.
Yes, sir. It got disconnected. Mm,
Yeah, it is clear.
ANOVA, analysis of variance, is a statistical method used to determine if there are statistically significant differences between the means of three or more independent groups. It is commonly employed to compare the mean scores of multiple groups and assess whether these differences are due to actual group effect or random variability. ANOVA is particularly useful when analyzing data with one independent variable and one dependent variable.
One
definition
sec.
of ANOVA.
One sec, Ankit. So, dear students, please you keep in mind that is two factors are there for the change in the mean score. One is the random variability, another one is the intervention effect. Okay, so actual group effect, another one is the random variability.
Random variable.
Yeah, so these two things are there. We have to find out through the ANOVA whether it is random variability or it is due to the group effect. Okay, next.
Assumptions of ANOVA. Continuous dependent variable. The dependent variable, which is the variable being measured, should be continuous. This means that the data should be at either an interval or ratio measurement level. Independent group. ANOVA requires independent groups, meaning that the observation within each group should be independent of each other. This ensures that the data collected from one group does not influence or relate to the data from another group. Homogeneity of variance. Homogeneity of variance, also known as homoscedasticity, assumes that variance between each groups are approximately equal. This means that the spread or variability of scores within each group should be similar across all groups being compared.
Hmm.
So shall I move forward?
Yeah.
Purpose of ANOVA. ANOVA differs from t-test as it compares multiple groups, while t-tests are limited to one group. Assumptions of ANOVA. Assumptions of ANOVA include normal distribution of data, equal variance across groups, and independence of observation. The F statistic in ANOVA reveals the variability between and within samples, aiding in determining group differences. ANOVA is crucial for comparing group means simultaneously and assessing relationship between variables.
Okay, Ankit, this
Yes, sir.
t test you have written, na, that
Yes,
will
sir.
be the small t.
Oh,
Huh? It should not be the capital T.
that is it. Is it correct now?
Yeah, two t, another while t test, that will
Oh,
be the
sorry, sir.
small
Sorry.
t.
Sir, what is F statistics in ANOVA?
That is the ratio between the group mean square divided by the within group mean square. So between group variance divided by within group variance. Because we have to find out whether the between group variance high or not. Our tendency will be to maximize between group difference. For example, experimental group and the control group. Okay, and if you noted that is the after the intervention, there is no significant difference between experimental and the control group. That means between group difference is not there. But after intervention, you have noted that is the between group variance higher than the within group variance. Then you can tell that is the intervention or the independent variable has effect on the dependent variable. This is clear.
Yes.
we have to maximize the between group variance. That will be our research design. And this part is most important part. Between group variance, that should be high. Okay. Ankit, anything more?
Yes, sir. One-way ANOVA and two-way ANOVA.
Okay, two-way ANOVA not today. Next time
Okay.
we'll discuss about the two-way ANOVA.
So one-way ANOVA.
Yeah, one-way ANOVA.
Definition of one-way ANOVA. One-way ANOVA is used to test the claim that three or more population means are equal, comparing different groups or treatments. Variables in one-way ANOVA. The response variable is the variable being compared, while the factor variable is the categorical variable defining groups like race, political party, or color. Assumptions of one-way ANOVA include random sampling, equal variance among sample and normal distributed residuals. Hypothesis in one-way ANOVA. The null hypothesis states that all means are equal, while the alternative hypothesis suggests that at least one mean differs from the other. Example: classroom divided in 3 rows, front, middle, and back, to analyze factor influencing student behavior and performance. So then we will discuss the differences in other class.
Okay, these are not required. These are not required. Drop it now on Ankit.
Okay, sir. Thank you, sir.
Acha. When you want to do the ANOVA by using the non-parametric statistics, then which statistics you will follow? That is the Kruskal-Wallis statistics.
Kruskal-Wallis test.
Okay. You have to follow the Kruskal-Wallis statistics.
So can we explain it?
Yeah. I am showing it. Is it visible?
No, sir.
Acha. One sec. Okay, now I am showing you. First you click Analyze. Then you go to the non-parametric test. After that, you will go to the legacy dialog. Then you will go to the K independent samples. There is one Kruskal-Wallis H. Is it visible to all of you?
Yes, sir.
Okay. So grouping variable is shakes. Define range. Minimum is 1. Maximum is 3. Continuous. And total variable is total essay. Now I click it. Okay. There you can find out options. You can click descriptives. After that, continue. Then you click the Kruskal-Wallis test. Then OK. Now I am sharing the output. This is the output. Is it visible to all of you?
Yes, sir.
So,
Sir, why we choose Kruskal-Wallis test?
হ্যাঁ রে বল কোথায় আছিস? আচ্ছা yes, when we want to find out the differences more than two groups. Okay. And the data are not normally distributed. Okay. At that time, we can use the Kruskal-Wallis test. So this is the Kruskal-Wallis test. Now again, you will find that instead of the mean and SD, it is written mean rank. Okay. So when you want to present, if you find that your test statistics is significant, in ANOVA, we have noted there is no significant difference. Here also we find that there is no significant difference. Okay, but if you find the significant difference, then you have to interpret this data by the mean rank. Most of the time I find that is the researchers, they are using mean and standard deviation. But for the Kruskal-Wallis test, you have to present the mean rank. Okay. This part is important. This is the mean rank. The mean rank also similar to the level of parametric test, that is the mean. And there you have noted that is the higher mean in case of the male, and transgender mean is very low. Here also you find that is the mean rank is low. Okay. In comparison with the other two groups. So this Kruskal-Wallis test is very important. If you find that is your data are not following the normality. Here degrees of freedom also 2. Because 3 groups are there. The Kruskal-Wallis value is 4.84. This is the Kruskal-Wallis value, and this is not significant, 0.09. Now here you can find out the graph also. This is clear? Hello.
Yes, sir.
So you can get the graph. You can share the graph. If you want to share the graph, that is also possible. I think similar graph is possible in case of the uh, general linear model. Maybe the compare means one-way ANOVA. We can get this graph, maybe, but I'm not sure. Okay, what is that ANOVA result? No, it's post-hoc test. No, it is not. One sec, I have to find out. One-way ANOVA. After that, options. I have to click descriptives, correct. Descriptives, then continue. There is one means plot. Then continue. Then okay. So now you can click this one, graduation. Total. After that, you click create graph. Okay. Then the bar chart. So now you can get the graph. All the values you will get. If you want to show, you can show it. Okay. Another thing,
Yes.
you can make the graphs, then chart builder, then okay. After that, you can click this one. Next, you can click this is visible.
Yes, sir.
No, no. Is it visible, chart builder? No. I have to share.
Sorry, the voice is.
Is it visible now? So this is the total essay.
No.
You will
Yes, sir.
click it here. Okay. And your x-axis, is the education. You can click it here. Education and the mean. If you want to change, you can click here, and here you can change your data. This is the minimum, maximum. Scale type is linear. Okay. Chart appearance. If you want to change the color, you can change the color. If you want to click the basic elements, if you want to transpose the data, that you can do it here. So it is better not to use this one, but to follow the legacy dialog, or directly going to the data and make the chart. That is better. You have to double click and then you have to select. After that, you can make the chart. Okay. So now I want to close the session. I think you have understood what is the purpose of ANOVA and how to calculate the ANOVA. Besides how to calculate the Kruskal-Wallis test, that is also clear to you.
Yes, sir.
Okay, thank you, Ankita. Thank you, Anthony. Thank you, Sophie. Ankit, Farah, thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.